Ever wondered how websites like Netflix, YouTube, and Amazon handle millions of requests per second, delivering seamless experience while staying online 24/7? The answer lies in one of the most powerful tools in modern infrastructure, Layer 7 load balancers. In this video, we will dive deep into Layer 7 load balancers, also known as application layer load balancers, and why they are critical for routing, optimizing, and securing web traffic. We explore how Layer 7 load balancer works, the difference between Layer 4 and Layer 7 load balancing, how they handled HTTPS and API requests, and we talk about some algorithms that being used. First, what is the Layer 7 load balancer? Before we dive in, let's understand where Layer 7 fits in the networking stack. The OSI model defines different layers of networking, and at Layer 7, which is the application layer, traffic is handled based on the actual content of the request, not just its sorry, not just its IP address or port. Layer 4 load balancers work at the transport layer and route traffic based on IP addresses and port, like TCP, UDP. Layer 7 load balancers operates at the application layer and make decisions based on HTTP headers, URLs, cookies, and request types. Okay, let's try to understand how it works. Unlike Layer 7, which blindly forward traffic, unlike Layer 4, unlike Layer 4, which blindly forward traffic, a Layer 7 load balancer can inspect incoming HTTPS requests and route them based on URL paths, request types, and even user location. API gateway load balancing route API calls to the right microservices, content-based routing, sending video requests to a streaming service and image to a CDN, for example, user geolocation-based routing as well, basically directing EU users to EU servers and US users to US servers. Okay, and you can understand here how it works. It's not like just taking the data and send the request. No, it will also reshape the data. Um, and the benefits from all of that, first we have what we call a smart traffic routing, because routes request based on URL, HTTP method, cookies, and headers. It's a better security because it protects against DDoS attacks, bot traffic, and malicious requests. Also improved user experience because reduced latency by optimizing responses. It's efficient in microservice communication because it helps in API gateway load balancing. Also, it's great in SSL termination because it offloads SSL encryption to improve back end in the back end performance. So again, let's understand how it works again. So when the clients are trying to send, it's basically an API gateway load balancing. It's a round API calls to the right servers or to the right server. It will have content-based routing. It will send video request to streaming servers and image to a CDN or maybe an authentication to authenticator servers. Also, it can use geolocation-based routing as well. So it's not just it's like it has more in its hand than four layer or layer 4 load balancing. Okay, so where this is used, where the layer 7 is used. Layer 7 are used in CDNs because ensuring fast delivery of pages and media. It's also used in API gateways, managing microservice traffic efficiently. It's used in streaming services like Netflix and YouTube. Also, it's used in e-commerce. Again, a layer 7 microservices, it's a service. It's basically a load balancer that will will distribute all the incoming requests, but also will have access to the data to modify, maybe route it, do something like it, as you can see here this in this diagram. In the next video, I will just create another video that talks about what all the differences between layer 7 and layer 4 load balancers.